Hello everyone, welcome to my class, Math Lesson with Miss Kenny. Our lesson today is about graphs of linear functions. But before that, let's take a look at the previous lesson. You've learned about arithmetic sequences. Arithmetic sequences, also known as linear sequences or linear function. For example, sequence of odd numbers here. 1, 3, 5, 7, 9, and then 3 dots mean the sequence goes on forever. And then you've learned about the nth term. You've learned about how to find the position number using inverse function. Now, the linear function here, or simple function, can be represented in 3 forms, using mapping diagram, using set of ordered pairs, and using Cartesian plane. Let's take a look. First one, mapping diagram. I was using this to explain about function. A function has input to get an output. That's why I'm using only 3 inputs here to get 3 outputs. And not unlike the sequence here, the sequence goes on forever, but not with the function. In other words, function has a limitation here. So, the next one is set of ordered pairs. You can represent functions, linear functions, in set of ordered pairs. When you are using set, you need to use curly like your curly hair, curly brackets here, like this. And then set of ordered pairs. It means inside the curly bracket, they are ordered pairs here, and each pair is separated by comma here. Inside these brackets, there are the position number, followed by the term, and then the second position followed by the second term, the third position followed by the third term. This is how we use set of ordered pairs to represent linear function. Now, next about Cartesian plane. Cartesian plane, also known as number plane or two-dimensional plane. Okay, but I'm using this Cartesian plane. Okay. The Cartesian plane named after René Descartes. He was a French mathematician. This is his photograph. Okay. Now let's learn about parts of Cartesian plane. Okay, as you see on your screen, it's a graph paper. And then I draw horizontal line and I label the horizontal line as X. Okay. And then the vertical line, I label the vertical line as Y axis here. So the arrow here means goes on forever. This arrow means goes on forever. The line goes on forever. So, see, the horizontal or the x-axis, the vertical, the y-axis. The x-axis and the y-axis divide the graph paper into 4 parts, as you can see. 1, 2, 3, 4. Start from the top right side here. We label this as first quadrant. Okay, and then in anti-clockwise direction, this is the second quadrant, and then this is the third quadrant, and then this is the fourth quadrant. So we label the Cartesian plane in anti-clockwise direction. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. See this part? The x here, the y here. There is no number here. That's why we need to generate the numbers. Remember, Cartesian plane also known as number plane. So where is the number? Or where are the numbers? Let's take a look at this. The axis, x-axis and y-axis, okay, intersect at this point, right? This is called a point of origin. Okay, origin is the point where the axis of the system intersect. So let's label this point O. Start from O. Imagine you are standing here, and then you turn right, and then you walk. See, you walk. Imagine yourself walk. As you go to the right, the numbers get bigger. 1, 2, 3, and so on. So the movement here is horizontal movement. And when you move to the right, it means you move to the positive direction. So we start from horizontal movement. And then, what about if you turn left and walk? What happened? See? It means you are going to the negative direction. And since it's negative, so the numbers are getting smaller, okay, because it's negative. Next, after the movement, horizontal movement to the right or to the left. Now, from the origin, you can climb first up. If you climb up, it means you go to the positive direction. So, as you go up, the numbers are getting bigger. So, if you can go up, you can go down or climb down. If you climb down, it means you are going to negative direction. Since you are going to negative direction, it means that as you go down further, the numbers are getting smaller because it's negative. Okay, this is how we labeled the numbers on Cartesian plane. Start from the origin. The movements are horizontally. If you move horizontally to the right, you move to the positive direction. If you move horizontally to the left, it means you move to the negative direction. And then the same happens if you climb up. It means you are going to the positive directions. And if you go down, it means you are going to the negative directions. Okay. So, example in Cartesian plane. I'm using sequence again. And I'm going to use the set of ordered pairs here. Here in Cartesian plane, the ordered pair start with the x coordinate, followed by the y coordinate. The same here, x coordinate, y coordinate, x coordinate, y coordinate. So let's change the name into set of coordinate pairs. We can use this to plot the graph, okay, here, like this graph. This is the first quadrant, this is the second quadrant. When you plot this, the first pair here, 1, 1, it means the x-coordinate, the movement is horizontal, one step to the right. One step to the right, and then this is 1, positive, it means climb up 1. So, you go to the right, one step, and then climb up one step. the next ordered pair or coordinate pair, 2, 3. 2, it means go horizontally to the right, since this is positive, 2 steps, okay, 2 steps here, and then climb up 3 steps, 1, 2, 3 here, get here, okay, and then 3, 5, it means move horizontally 3 steps to the right, 1, 2, 3, and then climb up 5 steps to climb up 1, 2, 3, 4, 5 here, and then connect the dots. Don't forget to label. Since we are using this symbol, you need to label the y-axis as the nth term and the x-axis as the n, or the position number, to match the equation here. Okay, this is why we call arithmetic sequences linear functions. Okay, see you in the next video.